Welcome. In this lecture, we would understand data interpretation. We will mainly focus on the tricks and the techniques to solve data interpretation problems quickly, and the basic idea behind solving those is mainly imagination and visualization. Now, most of the students are struck up when they see calculations which require really comprehensive understanding of the concept. So what we'll do today is understand the type of questions, we'll understand what are the basic techniques we need to analyze or apply for data interpretation, and then work around some shortcuts. So the questions are basically either in the form of graphs, pie charts, line charts, tables, and rarely they are in the form of scatter diagrams. Sometimes the questions are also asked as caselets, that means small passages are given based on which you have to analyze the data. Now, for all of these kinds of questions, the basic tricks that we need to understand is the basic quantitative techniques that we need to apply are understanding and calculating the percentages, growth rates, approximation, unitary method, cross multiplication. So these are some of the basic methods that we will apply nearly in most of the problems which can be solved through these methods. And then this is a key idea that I usually tell students what to do. So what is important is, on a question on data interpretation, usually you have 4 to 5 subsections that are asked. Now when there is, say, let's say you have a table and you have to calculate the totals for solving question A supposedly. So those totals would again be applied to question D. And sometimes it's such that you have to calculate the totals, and those would be asked in question D, would not be asked in question A, but some of it might be applicable in question 2. So that means if you are solving the questions in alphabetical order, you might take a lot of time. So the best idea is to read all the questions at the first go and see what all kind of data is required. So if some of the questions require deriving it from the total, start working with the totals first and then proceed on. So these are some of the techniques that will save time in an exam where you are really running short of time. Also, of these 4 or 5 questions, there would be just 1 or 2 questions that would require really time consuming calculation. So you can either leave those for towards the end, or you could apply techniques for approximation that we will discuss further in this video to work around quickly for solving such questions. Now the first thing that we will understand in this class is approximation. Now this is the key aspect for most of the questions that are asked based on tables and the questions that require lengthy calculation. So most of the students are struck up when it comes to approximation. We'll learn some quick tricks onto how to solve the questions of approximation. Now when there is a question of approximation, the first thing that is important is to look at the choices. If the choices are really far away, say for example question 1, if the choices are 2, 5, 6 or say 1, that means the choices are really far off and you can easily say what would be the answer. However, if the choices are close by, say 2.5, 2.3, 2.5, 2.8 and 2.9, what we will do? Then you will need to apply bit more of approximations. Now how to work around a question like this? You have 1789 divided by 762 and the exact answer we know is this. Now when we apply the technique for approximation, let's say I approximate this value to 750. Now the main idea is to approximate the values close to 0. So once you have 0 in the denominator and the numerator, it would be easier to solve. So for example, if I reduce 12 here, that makes it 750, and on the top side, by visualizing this, I can say it's more than double. So I'll do more than double. So I'm reducing 12 here. So double of 12 is 24. So I'll do more than 24. So let's take a number which makes the last figure 0. So then I can say 29 would be the appropriate number. So I can say 1760. So this is one way of approximating. Then I can cancel out the zeros and solve it in a much quicker way. Another technique that I usually work around is, you take 750, then another 750 will make 1500. Then if I do another 750, that will make it 2250. That is too way far away from 1789. So what I need to do is, let's break this 750 into 3 parts. So if I break this 750 into 3 parts, I can get 250, 250 and 250. Now let's simply add 250. So 1500, I add 250, that makes it 1750, and that is very close to 1789, and this 250 is 1/3 of 750. That means I am using 2 times 750, that is 2, and 1/3 of 750, that is 2 1/3, or I can also write it as 2.33, and I can put a bar that says it's a recurring decimal. However, so my answer I can say would be close to 2.3, and if I look at exactly, the answer comes to be 2.34. So that means this is one of the techniques that you can apply for approximation. I repeat again, what you can do here is, there are 2 ways in which I am explaining this approximation method. The first is, you do 750, you reduce 12, and then by visualization you can see it's nearly double of it. So you double 12, that's 24, and then since last digit is 9, I make it 29 so as to make the last digit 0. So it becomes 1760 divided by 750. I can cancel out the zeros and I can simplify this fraction to work around. That is one method. The another method is, I add 750 and 750, that gives me 1500. Now if I add another 750, it gives me 2250, which is very far from the given numerator. So what I do is, I divide this 750 into 3 equal halves, that is 250 each, and I add 1 250 to it, that makes it 1750. Now this 1750 is very close to the numerator. That means my answer would be 2 times 750, so 2, and then 1/3 times of 750, that is 2 1/3, that is nearly 2.33. So that's the first thing. Now in the second set, what you have is, what is the percentage of 468 of 21428. Now if I simply say 100% makes 21428. So as you can see, in most of the questions what I am preferring is applying unitary method. So that's the easiest way and the fastest way to work around. So 1% would be nearly 214. So I can say 2% would be nearly 428, and now this is 468. Now if I do 3%, what it would be? It would become 3 times of 214, that is 632, that is too far away. Now my answer is, I already have 428 and my answer is 468. So my answer would be closer to 2 rather than closer to 3. Now let's do a halfway of it. So when I say halfway of it, that means half of 214 would be 107. Now if I had 107 to 428, that gives me 535. Again, this is too far from the value that we need to derive. That means if I take 2.5%, that also is very far from my answer that I need to come on to. That means my answer would be closer to somewhere which would be 2.2% nearly, because it's far from this, and closer to 2.5 is 335, which is again a much bigger number than this. So my answer would be closer to nearly 2.2, and the exact answer, as you can see, is 2.1. So that is another technique of approximation that you use here. Rather than solving the complete sum, if you solve out the complete sum, you can say 468 divided by 21428 into 100, and then you solve the values and you say it would be nearly 2.18%. So rather than doing that, you are trying to simplify it, because if you put the decimal place here, ignore the last digits since they are smaller than 0.5. You take 214, double 214, that is 428, and you need to go close to 468. So that means you will go somewhere around 2.2%. As you can see here, we have calculated 3% and 2.5% for better understanding. And these type of question, when you solve once or twice, you will have a kind of good visualization to get closer to approximations much quicker. So in the first round you might calculate 3%, but in the second round you would have an intuition that if I do 214 into 3, this digit would be 6, and this, if this is 6, this is very far from this, so that my answer can never be towards 3. So my answer would be closer to 2 in all possible cases. So these are the way you need to do approximations for quicker understanding. Now, when it comes to fraction, I usually recommend don't solve the fractions, keep the fractions as it is until necessary. So if it is necessary, if the answer is given only in decimals, then definitely go ahead and solve the fractions. Otherwise, there is no need to solve the fractions. Now let's say the blue bar denotes the wheat production and the pink bar denotes the rice production. Now in which year was the wheat production highest? Now whenever a question like this is asked, what you have to do is, you have to do the current year minus the base year divided by the base year into 100. And this is another standard formula that you must remember for all data interpretation questions. You might have come along with binomial problems and binomial equations which help you solve the growth rate problems, but don't go into that detail. You can simply solve the questions with a simple formula, that is current year minus base year divided by base year into 100. Now if you remember this formula and you try to apply it universally, now what would happen here? Let's calculate it for 2006. What would happen? Wheat production is 50, 55, 60 and 65. So let's say for 2006 it would be 55 minus 50 divided by 50 into 100. For 2007 it would become 60 minus 55 divided by 55 into 100, and for 2008 it would become 65 minus 60 divided by 60 into 100. Now if I simplify this, it would be 5 by 50, it would be 5 by 55 and it would be 5 by 60. Again simplifying, 1 by 10, 1 by 11 and 1 by 12. So I can say the highest production would be in year 2006. Why? Because if you have higher denominators, the fraction would decrease and it would be lower in the answer, because if I simply say 1 by 2 or 1 by 3, I can say 1 by 2 is nearly 50% and 1 by 3 is nearly 33%. That means 1 by 2 is bigger. So if your denominator is smaller, your answer is bigger. So if your denominator is smaller, you will have a bigger answer, and therefore highest value of production would be in the year 2006. Similarly, if it asks about rice production and which year would have the lowest rice production, you will again do the same thing, current year minus base year by base year into 100. You will do it for all, and let's say you come up with the similar answers. So you would have, for the last one, you would have 5 by 65 into 100, and that 5 by 65 would be the lowest fraction, because in this case you would have 5 by 65, in this case you would have 5 by 60, in this case you would have 5 by 55. So these would be the three ones for the rice, and then you can say this would be the lowest among the three. So year 2008 would have lowest increase in the rice production that could be visualized. Now next question is, sometimes there is question that is asked to calculate averages. Now when you need to calculate the average, there is an interesting thing that you must understand is, you must look into the figures and see if they are close to one another. So for example, let's say this graph, you have all the figures that start with 7800. Now if I take away 7800 and work around the remaining ones, so you have 14 here, you have 29, then you have 108, then you would have addition of 22, and finally addition of 120. That means you will add all the remaining values except 7800, So when you add all these values, you get an answer of 293. Now this 293 is divided among 5. So 293 divided by 5, I can simply say 5 5s are 25 and 4 carry over. So you would have 8.30, that is 6, 58.6. Now this 58.6 I can add on to this. Therefore, the average of all these values would be 7858.6. So that's a simpler way to calculate the averages rather than going into the details of each and every thing, adding all the values together. What you can take aside is take the common values out and then add the remaining values. Or when you total out the remaining values, take a average of the remaining values and add that value to the base value that you had separated in the starting. So that is how you work around quickly with the averages. Now the next thing is pie diagram. Now this is a main area where most of the students are stuck up. The simplest thing I would say here is you have to remember two things. First of all, a circle makes 360 degrees, that's the basic key. And once you know that circle makes 360 degree, you can solve each and every problem. Now what is given here is the total sales is 6 lakhs, and if it is asked what would be the sale of cement, how would you calculate this? When I say total sale is 6 lakh, I can say 360 degrees give you sale of 6 lakhs. So 1 degree would give you sale of 6 by 360. So 72 degrees would give you a sale of 6 by 360 into 72, 36, 10, 2, and then you would have 12 by 10, that is 1.2. So I can say the sale of cement would be 1.2 lakhs. Now this is again a simple unitary method that you need to apply when you are given with degrees. Now another interesting question would be, what would be the percentage of sale if I take supervisors, timbers and laborers together? Now if I have supervisors, timbers and labor together, I don't know what is the degree for timber. So first of all I need to calculate that. So I'll add up all the remaining degrees and subtract that from 360. So that will give me the answer for timbers is 36 degree. Now it is given that the sale of these three together would account for what percentage of the total. That means 54 plus 36 plus 90. So it gives you 54 plus 36 is 90, 90 plus 90 is 180. Now this 180 out of 360 accounts for what percentage? So I can say it would simply account for 50% of the total. And if that graph is drawn to the scale, you can simply say here, this line denotes 50%. So 50-50, this line denotes the, breaks the graph into, the pie chart into half. So you have 50% on that side and these three would again make up 50%. So that is how you solve problems like these for pie graph. So this is the first example for pie diagram where you are given degrees. The next case we will take is a bit complicated and you must understand this carefully. Now to solve problems like this, there are n number of methods given in n number of books that you can refer. But what we will work around is the simplest of all. What is given here is, you are given the total weight of the sweets that are available at a sweet shop. That is, the total weight is 250 kgs and you are given the proportion of the weights for each of these. You are given the total cost of the sweets, which is 25450, and you are given the individual percentage of the cost. Now, if you are given to calculate the cost of 5 kg of milk cake, how can you do that? Now the first and the foremost thing that you need to understand here is, you have to see if the ratio or the proportion of weight and the proportion of cost is same, then you don't need to go further into the details. You can simply solve it with one step. Let's say we'll do it for the milk cake first because it's 2% in both the cases, so this makes the question simpler. Now we'll work around for milk cake and you are asked to find out the cost of 5 kg of milk cake. How you can do that? The total weight is 250 kg. Now 1% would make 2.5 kgs and 2% would make 5 kgs. Now if I know the total weight is 250 and the total cost is 25, so 250 kgs bear you a cost of 25450. So 5 kgs would bear you a cost of 25450 divided by 25 into 5. So that's one way of solving it. Another way of solving it is, since the total cost is 254.5 for 1%, it would be 254.5. So for 2% milk cake, it would be double of this. So 250 and 250 is 500, 4.5 plus 4.5 is 9. So 500 plus 9 is 509. Again a shortcut to solve this. So I broke this into 250 plus 4.5. I double this and I double this individually. So this becomes 500 and this becomes 9. Now I add this, so it is 509. Now, so 2% would have a direct cost of rupees 509, and if I calculate this, I would again get rupees 509 as the answer. So this was a very simple method to solve the problem when you have equal proportions in the cost and equal proportions in the weight that is given. Now let's complicate this question further. In the next set, what is asked is cost of 5 kg of Kalakan. Now when you are asked about Kalakan, let's look into the weight. By weight, Kalakanth is 10% and by cost it is 17%. So solution for this won't be as simpler as we did it for milk cake. Now let's move on to solving this section. Now for 250 kgs, 100% make 250 kgs. So 10% of the Kalakanth would make 25 kgs. That's the first thing you can solve here. Now remember what we did earlier in the fractions. Don't solve fractions until necessary. So keep prolonging the fractions till the time they can go. Now here 10% of the Kalakanth makes 25 kg, and so what we will do is we will first find out for 25 kg how much is the cost, and then we will move around for 5 kg what would be the cost. Now as I said, 17% is Kalakanth. Now 1% would be 254.45. So 17% would be 254.45 into 17, and this makes up how much Kalakanth? That is 25 kgs of Kalakanth. So 1 kg would be 254.45 into 17 divided by 25, and 5 kgs would be into 5. Now as I said, if you keep the fractions as it is until end, it would be easier to solve rather than if you multiply this first and you get a big number and then you again start dividing, it would create whole lot of mess. Now you would have 1 and 5, and 5 5s are 25, then 0, and then you would have 40, that is 8, 9. So 50.89 into 17 would be the answer. Now if we simply calculate, 17 5s are would be 85, so it would be close to somewhere 850 because it is 50, and since it's 51, now another thing I can do here is if I add 17 here, it would be 867. So my answer would be definitely less than 867. So if I have various choices, I can say my answer would be less than 867, but way more than 850. So since it is 50.89, so I need not to calculate it exactly. If the choices are far about, I can say simply what would be the answer. However, the exact answer here would come as 865.3. So this would be the cost of 5 kg of Kalakanth. So I hope you understand the difference when you have the same weight and cost ratio that is given as we did in the case of milk cake. However, if there is a different weight and cost ratio that is given as in the case of Kalakanth, so we need to calculate it a step further. So these are some of the data interpretation questions and the various tricks to solve the data interpretation questions. We might work around more questions on data interpretation if required. You can leave any doubts as comment below the video. Have a good day ahead.